And we're back. So let's see how did the print go, and let's test our product. So actually, I had the pleasure to play with this a little bit off camera. I think this is uh, this is really cool. Let me try to get it in focus here. So this is the product, or this is our product. As you can see, it like has this nice spherical form, and this is what I was shooting for, and I'm really happy with this result. So the form itself is spot on. Actually, it rests very well as well on the desk. So if I'll bring the surface here, so this will be kind of how it looks like on a level surface. My hands are shaking, but it's in reality it's very stable. And the effect that we were looking for is actually there. So this is how it looks like, or how it snaps back. So let's do this one more time. Okay, so the effect is super cool. This is the salt. As you can see, this is the form. And let's review this a little bit. So the holes themselves look a little bit, I would say, too big. So I would go ahead and change that in the next iteration. I checked actually another salt shaker offline, and I think we could go from 2.5 millimeter here to 2 millimeters. So that's one thing. Second, actually this is something that is very obvious as well in the print. You could see that the print wall is too thin. Even here it actually broke. So this will not hold any salt at this point. So again, iteration mindset and iteration like or design sprint mindset. The first sprint is a success. Like it holds very well the magnet. The magnet did not catch into the nozzle or the extruder or anything, so that's good. The issue here, I think, it will be in the wall. So the wall needs to be much thicker than that. I think we had it at 1 millimeter. We could I would say even triple or quadruple that. The reason I'm saying quadruple even is that I feel that the volume is too big. So this is a lot of salt in that small shaker, right? We made it this big for an ergonomics is anthropometrics from an like anthropometrics standpoint. So for the human to be able to hold it comfortably, that would be how big it should be. But this does not mean that we need to fill it up to the end with salt, right? So these are two different parameters. And I think this is one of the cool things I always admire about 3D printing, so that you, in typical or conventional injection molding, you will be constrained by a ton of things, but in 3D printing you will not. So in 3D printing you could just say, okay, my ergonomics are telling me, or anthropometrics are telling me I need to be this big, but my insides I could still play with them, and you will still control all of the printing parameters by infill ratio and all of that. So you're not losing much plastic as well. So you could have a good successful product while still meeting both ends of the technology and the human and user side. So the snapping effect is pretty strong. So you could even hear it in the clacking sound. Very, very strong. So this means I could still afford to move my magnet a little bit inwards. So that means that I could make my wall a little bit thicker. The reason I'm saying this, that you could see in, let me again get it in focus. You could see in the camera that the magnet's slightly visible on the white. On the black one, you won't see it. So on the black one, it's super, you will be able to, like, yeah, see, it's fully invisible. You cannot see it. But on the white one, it's a little bit on the edge. So I would make that particular wall a bit thicker too. So again, we talked about the wall thickness. We will, like, I would say quadruple that. On the black, it printed much better, so it's not leaking on the end. So if I, like, when I tried to fill that one with water, it actually filled well, quite nicely. But this one was like, yeah, I think maybe it could be a printing issue, it could be a filament issue, but again, I would basically quadruple that. So the next thing is the plug or the cap. So the cap is too small. Or actually too wide to fit, so it's not fitting very well, so we need to fix that, probably due to the shoulder. that we had there. So remember, if in the 3D model we had like a small shoulder on the edge, so I'm gonna remove that shoulder, and now by making the thickness, the wall thickness, a little bit thicker, we could afford to actually lose that shoulder completely and rely on the surface friction to keep the cap or the plug in place. So here you go. I think we covered we covered everything that I see as design improvements between revision 0, which is this one, and revision 1. I think overall the product is super cool, super nifty. I like it, and I think it's one of those products that you will look at and have, like, this smile in your face when you have it. So I think it's aesthetically very pleasing to look at. And yeah, like once we're done, I think I'm gonna post it on the online 3D printing stores, and you could actually see it and download it yourself. But let's fix first some of those issues and do another test print to see how we fixed everything. So let's start digging. All right, let's start. So first things first, we need to rev up that part. So revving up is basically my way of keeping things in revisions, and here basically it's just good practice for designers in general to ensure that we are having a good kind of history of the product. So of course you could choose not to do that or do it in other ways, but my way of doing this is basically I go ahead and I save the file in a different name, so I could revert back. If I screwed up big time, I could basically revert back and go to the older revision. So first things first, as we talked earlier, I would again, right now my shell thickness is 1 millimeter, which gives me a lot of volume inside. So let's start maybe 4 millimeters. So this would reduce the overall volume quite nicely. Let's see if we go 6. 6 will not be acceptable, a wall collision. So 4.5 is still acceptable. But yeah, I don't know. Like, I feel more comfortable with 4. Reason being, I think here as well we have the holes, and I would like to have kind of a uniform wall thickness. So let me do that. So 4 millimeters it is. So far it's not angry at me, and this is why. This is because if you remember from the previous CAD modeling session in revision 0. I related stuff to each other, right? So this is very good practice as well in CAD modeling, if you will. So, but let's go a little bit back before all of this. So basically, this is how it looks like at this stage. This is good. If you remember as well, we said we want to move the magnet slightly inwards. So I would do that. So right now it's at 1 millimeter from the wall. This is very strong. So maybe we move it to double that. So let's make it 2 millimeters. So we could reduce a little bit the magnetic effect of latching, because I feel it's a bit too strong, right? So if you think about it, it's like it's maybe too strong for that application. And remember the shaking sound. It's not very visible or it's not very audible in the black one. In the white one either, it's like maybe there is some clacking sound inside, but I think our tolerances were spot on. So I would leave everything as is, but I would just raise this to 2 millimeters. So that's basically how it's gonna be. So again, I'm gonna leave the spaces as is. I'm gonna leave the spaces around it as is per our previous calculation. So I'm not gonna mess up with that. This particular one is basically, if you remember here, we were shelling the entire body. Then we were removing that surface for a shelling purposes. Like this shell feature refused basically to have it without this. So I'm just basically compensating for that removal. Or maybe there's a better way of doing it, but I don't know it. So it's fine. CAD is always coming up with new things every day. So yeah, I would say let's go here to 4. And you see here, this is a very good example of if you don't have your constraints well defined, or if you don't have your relationship set, you have to go and enter that 4 millimeter. If I had it, I would say up to surface, which is what I usually do. I could say up to surface. but here for some reason it's behaving in a different way. So I'll just go ahead and put it at 4. So this was why I didn't do it apparently. So, but if you put it at 4, this is basically how it looks like. It looks pretty much cool. I think we reduced the volume inside volume a little bit to a reasonable amount. One of the things that you will feel in this one, or like when you hold it, it's not visible on camera obviously, is that it feels a little bit light. So of course this is without the herbs or without the salt and pepper inside, but it feels light. It doesn't feel, it feels a little bit cheap, right? So I do not want that psychological feeling when you're holding it. So this is again, the making the walls 4 millimeter was again for me subconsciously another reason of making this a little bit heavier in density. So you feel that this is a product, you feel that this is something that you're holding. So I think with this, I think we're cool. I'm a bit bugged by this one. So what I will do is I'm gonna change my section to another view, which is this one. And I will cut this a little bit further down. So again, with the good practices that we just discussed. Okay, so let's comment a little bit here. So I added this again. I made this cut a little bit to remove some of the excess, I would say, material that was a result of the shelling at 4 millimeters. I made this I made this cut with a linked parameter. So I like it at 1.2 because this gives us, again, with the same mentality of at 0.2 millimeter layer, you will end up having 6 layers. If with the 0.3 millimeter layers, you will get 4. Again, this is my choice. Feel free to do it in other ways when you're modeling your product, but I think this is okay. Again, looking at it, I feel it's a little bit imbalanced, so I would actually go ahead and make it another 2 millimeters. Okay. And if you remember here, this gap, I just moved the magnet, right? I didn't adjust the cut. But again, since this feature or this extrude was made with, again, a link parameter, it adjusted automatically to what I wanted, right? So it's here programmed at 0.6 millimeter from the magnet. So when I move the magnet inwards by 1 millimeter, everything kind of adjusted itself. I love this when it happens. So honestly, this is one of my big satisfactions when it does. Okay, so here again, I played a little bit. I adjusted some fillets, and I found here this might be an aggressive corner, so I made it a little bit less aggressive. Again, we're trying to minimize the accumulation points on the edges, right? So the more the more you do your fillets well, the better the less accumulation you're gonna have at these corners. So I made this kind of around 2.5 millimeter, I would say, it fillet, and I will continue with that. Let's see if I could make this even better. Yeah, I can, but I need to do it around the entire thing. Cool. I will do that too. So I think now it's much less aggressive. This looks nice to me. So this triangular fillet or corner fillet looks super nice. I like it. So now we're gonna remove the shoulder from the cap as we talked. Okay, so here what I've done basically, I removed the shoulder that we had here. Again, this kind of deprived me from the from actually entering the cap or putting the cap on to begin with. So I'm gonna remove that. The plastic flexibility was not enough to counter the shoulder effect. So I'm gonna remove that. And actually, even further, I'm gonna add a 0.1 millimeter clearance here. So a 0.1 millimeter on a radial dimension will translate into a 0.2 on the overall diameter dimension. I think this is enough to give you a snuggly fit. But again, the good thing about this, we could print the body and the cap, and if it didn't work, we could just basically reprint the cap alone. So you do not need to redo the body as well. So this is one of the things that I usually do. And there is another technique, it's called partial prints, and I'm going to show you that maybe in a future video. But for now, I think the cap is okay. Okay, another dimension I just changed was the thickness of the cap. Again, the cap itself is a bit too thin. So if you look at the profile, it's like too thin in reality. Again, 1.2 millimeter on CAD gives you a little bit more of an impression it's bigger than it is in reality. So I just made that one as well bigger. Okay. Another thing I just did right now, I'm centering the holes of the salt and pepper shaker itself into a little bit outwards or a little bit away from the center. It has a better aesthetic effect, like I think in this case, and it's as well centered to our actual shaker itself. Like again, imagine the 3D effect as well here. So the salt will be flowing, force flowing here. So this it will be kind of your center at this stage. I'm trying to balance here engineering and aesthetics at the same time. So usually this is kind of the battle of good and evil. So you always need to play both advocates. Maybe now after looking at it, it's not very aesthetically appealing. So I'm gonna just go ahead and make it less than 12. I went from 9 to 12, so maybe I'll do like a 10. Let's see if that has a better effect. Yeah, that feels more right. So let's do it that way. Let's do it that way. Okay, so again, let's take one final look at the product. So this is how it's going to be sitting on the table. You're going to snap it in. We fixed, like imagine, again, now we're imagining as if everything is fixed in what we've done. The wall is thicker. The holes are a bit shifted. Yeah, we did not adjust the hole diameters, remember? So we need to do that too. So I forgot about that. Let's do it. Okay, so I think this is cool. I think I like it with the or I like the stage we reached right now. I think this is not how it's going to look like. Again, one interesting thing I've noticed as well when I was doing the printing is again when I paused the print to insert the magnets, and you could see it in the time lapse video that I had to mark the magnets, otherwise I would have been confused. So I tried the magnet offline on the white piece, which I printed first, or the white side, and it snapped. So after this, I basically colored the side that needs to be up on the printer. So you could notice this if you zoom in on the printer time lapse like video. So actually, let's go ahead and save and export to like the slicer. Okay, so with this, I think we're ready to go. So we could now export the model to our slicer or our to our printer SD card, and we could start printing. So it's the same idea. I didn't change any of the parameters except for the infill because now the model has like some thickness. So we need to accommodate that. Like we cannot go now with the zero of infill like we did before in the previous print. So with this, let's get going and yeah, let's see how it prints. See you after the print, and let's do another testing and of this iteration. See you soon. All right, so we are back now with revision 1 and the improvements that we have just printed. So basically, let's take a look. So as you can see, it's still very nicely curved, and I think now you cannot see anymore the wall issues that we had in revision 0. So revision 0, as you can see, had some issues here, and like the wall was like a bit too thin, and revision 1, or the improvement that we've just printed, is much better in quality. As you can see as well, like maybe if I could adjust the focus a little bit, you could see that the wall thickness here has increased, as we saw, and now you could hear the clackety sound that I was referring to in the CAD model. Like it clacks a little bit more louder for some reason, but I'm happy now with the overall quality. So as you can see here, even the parting line, or where we stopped the print, and this is basically something you need to kind of investigate a little bit why it happened. Maybe it's a printing thing, maybe it's not, I don't know. The black piece is the same, or the pepper half is the same quality. You see as well the dome and the very, I would say, like sometimes I feel they're like an aesthetic point for me, like the curves, or like the layers of the 3D print itself. So the black as well is equally good. So I would say both colors are nice, and when we snap them, you have this nice snap sound. And actually now with the increased wall thickness, you could see and you could feel it's much gentler. So it doesn't snap back very fast like in the revision 0. Revision 1 is much better, and both have the same shaking sound. So I think this could count as a delighter. If you do not, if we don't like it, we could actually remove it. One idea to remove it, it will be basically to put some glue when you are putting the magnet, and this will basically hold it still in its place, because there is no forces on this magnet other than the one in the snapping direction or the holding direction. So basically, if you glue that side, you're gonna be done, and nobody will be suffering from that glue. So basically, this glue will be inside, entrapped, encapsulated, and all is good. If you take, I would say, I would say, let me try to adjust the angle for you to see. Maybe I'm successful, maybe I'm not. Let's see. But if you could see inside, you'll see the holes going all the way through, and you'll see as well the kind of the protrusion of the magnet, right? So the protrusion of the magnet, excuse me, will be basically in the inside, and from the outside it's like super smooth. It's like very nice surface, which is like your perfect first layer, if you will, for the 3D printing enthusiasts out there. So last but not least will be the cap. The cap itself printed out very nicely. As you can see, it's a bit thicker, a bit taller as well, and as well it snaps very nicely inside. So it fits the geometry, and it's very snugly. You cannot fall. So this is what we were referring to earlier about. Let me do the same thing for the peppers, and you see both. Um, and again, I'm using it like crossing the colors, right? So I'm using the white one for the black one, so it will be acting as like kind of the signifier. And let me try to do this. For some reason, the black is tighter, but again, okay, and it fits. Okay, there we go. Uh, some opposition, but it snaps. I think this is a bit tighter than the white. I think it's because of the material shrink ratio. Maybe I need to adjust this a little bit, but again, if you see it from the bottom, both are kind of installed now, and they're going to work. What we just need to put now is some pepper and salt in these, and we're good to go. And again, let's check the leveling, and again on the same surface we checked before. I think it's nice. I think the leveling is pretty cool, and yeah, I think with this we could say that our product is concluded. If we wish to optimize further, we definitely can, but I'm very satisfied with this. So I'm gonna release it right now on the 3D printing like model websites, and you could download it basically from the description section of the video. Thank you so much, and I enjoyed this session very much. I hope you did as well, and see you all soon. Bye.